let's start here. Log in here as well. Zoom, it is. Check something. Don't connect the audio. Turn on. That is correct. Join. All right. Stay as a participant. That looks good. Okay. All right. Welcome, scholars. Happy holidays. All right. Hopefully you have you guys traveling for the holidays. Anybody doing anything interesting? You going back home for a bit? What you gonna do, right? Let me see. So, from we only have three live sessions remaining. So we have today. We're gonna meet today, obviously, because we're here. And then for the rest of the week, we're off for. Let me pull up my calendar real quick, we'll do our little synopsis like we've been doing. So we meet today. We'll do our first of 3 review sessions for the final. Basically, each session will focus on an exam. So today we'll focus on exam 1. We'll break for the Thanksgiving holiday. We come back a week from today on December 2nd. We'll focus on exam 2 that day. And then our last live session is that Wednesday, December 4th. And we'll focus on exam 3 along with those 2 additional sections. So then that Wednesday, December 4th is the last day of class. That's the last time we're going to meet live. And then that Thursday and Friday, December 5th and 6th, that's the reading period. So that's an opportunity. The school, classes don't meet during that time. So that's an opportunity for you to study and prepare for your finals. Again, right now, I'm still under the impression that I will be hosting your final, which only makes sense because we're remote. So you can anticipate your final exam to become available. That's Sunday morning, December 8th at 11:11 a.m. And it'll be due that Friday, December 13th at 11:59 p.m. And again, that Friday, December 13th is the hard deadline for all assignments, right? So idealistically, this is a great time to go ahead and get caught up on old assignments. If you are doing old assignments, going back to boost your overall score, I would encourage you to prioritize your exams because that's where you're going to get the most bang for your buck. The homework, I would encourage you to prioritize it last because it's going to be a lot of work for minimal points. The intent of the homework really is to kind of get you ready. Why are you looking at me like that? It's funny. It's to get you ready for exams. Okay, I can think that's the meat and potatoes. So, oh yeah, let me check that. Oh, let's go chill. Somebody, I think it sounds like somebody smoke detector or something of that nature. Mute. Okay. I kept hearing this, what is that beeping? I was like, and we don't have the beeping right here. I kept looking. My dog was looking at me funny. I was like, what is going on? It's just too early. I'm not really coherent. Okay, anywho. All right. All right, so I think we have some study guides at the bottom here. So yeah, exam 1 study guide. Let me check one other thing. I want to make sure those sections are in there. Manage. And I can check some other things as well. If it opens, let's go down to the bottom. Let's see. It does become available Sunday at 11:11. So there might be a slight extension. I know I said Friday the 13th is still a great day to focus on. Exam 3. As far as things locking out, okay, you might have a little bit more time, maybe, but you don't bank on that. I just want to check question details. I just want to make sure. So chapter 2, it should be also 3.1 and 6.4. Let's see, it is missing it, so I need to edit it. Let me go ahead and edit it right now. I'm glad I checked it. Yeah, it's definitely missing those. Okay. Okay, let me make that update right now. I need to update my other ones, but I guess I have to do it later. Let me edit this assignment. Yeah, that's fine. That's fine. Okay. That means I gotta change the thing, my main one. So it's chapter 3. Because if I don't do it now, I'm gonna zone out. 77, it's usually 150. I want all except those. Let's get rid of these guys. These do not work. Add. Okay, that leaves 39. And then I think the other was section 6.4. Is that from a different text? No. System of equations in two variables. Yeah, we want all of these. Add. Okay, that's decent. Saving that's fine. Okay, so I need to do that for my other groups, but I don't want to eat into you all's time. So I'll just have to remember. Okay. Oh, that's the study guide. Wait a minute. Oh, that's not for the final. I mean, that essentially works though. Actually it doesn't. Oh, there it is. Okay, I checked the wrong thing. Okay, I think I updated the wrong thing. Let me check this. Final exam study guide. Okay, we could use the one. Let me list the questions real quick. Let's see. As long as it has the right sections, then we can work with it. Let's see. Yep, it looks right. Okay, so we can just use this. We can use this one document. How many questions? Total. Well, that's 110. Yeah. Okay, we can just use this one document. That's fine. So I shouldn't use. Let me. I mean, that's fine to change. I'll leave it for now because I usually do that from scratch anyway. Okay, so we can just use this final exam study guide. I was going to create 3 different documents, but that one document will suffice. All right. And I was, I was I just glanced at you all's grades. It seems like they're porting okay, like because it's supposed to be automatic, and I removed anything that it's not that you're not responsible for, that's not graded. Basically, like the attendance quizzes, those were just for attendance for those days. If it says practice not graded or attendance quiz, then either you're not responsible for it or the time is come and gone. Let me see. So final exam study guide. So we'll focus on this. Let me see. 110 questions. Let me see. So give me a random number between 1 and 110. Okay, we'll start with question 39. Right here. Ho, ho, ho. Okay. So for this function, construct and simplify the difference quotient. So this comes from section 1.4. Okay, difference quotient. Let's just take some notes here. So let's get a copy of this guy. Difference quotient is the precursor to a major topic in calculus. For our purposes, we just need to know how to evaluate and simplify a difference quotient. Here. Wait a minute, that's definitely not right. It should just be blank. Let's see, just a new. Come on. Oh well. Let's see. That's right. Yeah. Okay. Let me charge it for a bit now. Just a few seconds. Okay, so one way that you can go about this is like just evaluate the f of x plus h by itself first. You get it down as far as you can, and then tack on those remaining parts. Okay, that should be good. Okay, so let me see our f of x. Okay, so we're gonna say f of x, but we're gonna replace each x with x plus h. All right. So that's going to be x squared minus 9, but our x in this case is x plus h. So again, we're replacing each x. So then when we expand just f of x plus h, we're going to get x squared plus 2xh minus h squared. Sorry, not minus. But plus h squared minus 9, okay? I think that's as far as we can take that. So then if we go ahead and look at f of x plus h minus f of x, I'm going to go ahead and tack on my over h. So we take that result that we just got. Okay. Minus f of x. So we got to distribute a negative. That's going to be a negative x squared and then plus 9. Okay. And then all divided by h. So at this point, you know that you've done it right if you have cancellations like this going on. The 9 cancels the 9. Notice that the remaining terms all have h, so we can factor out an h from those remaining terms. We're going to have h on top. We're going to be left with 2x plus h. And then on bottom we have h. Now these guys can cancel. So then we get 2x plus h. So now here, you know, in college algebra, to find and simplify the difference quotient, it took up half the page, right? In calculus, you can just look at the f of x and just jump straight to a version of that. You almost jump straight to the end, just in an instant. Like we have maneuvers that take you straight there. So we got 2x plus h. Oh, my device. Come on. So let's turn this off. I might have to wipe my device. I don't really have anything on here, so I could just put it back to factory settings. What do we get? 2x plus h. A little bit painstaking. Generate. Let's go to question 88. Okay, list the potential rational zeros. So this comes from section 2.3. The rational zero tests are P over R Q. Let me see. So P comes from the factors of our constant term, which is just the 1 in this case. And then Q comes from the factors of our leading coefficient, which is 5. So on top, we would have 1. On bottom, we would have the 1 and 5. So it should just be like 4 terms, which is B. B looks correct. Yeah, right. Let's generate. Let's go to question 31. Write a linear function that has the indicated values. Okay, I think I'm gonna take my notes here. All right. So if we have our I'm just gonna put y equals mx plus b, right? So our y-intercept is what when x is 0. Well, we have our y-intercept is 8, so we have one term already. The slope, right? Let's see. So we have 0, 8, and we have negative 8, 0, right? So I think the slope is 1, right? If we use a slope formula, let me see. So if our slope is 1 and our y-intercept is 8, so then it should just be x plus 8. Let's see if x plus 8 works. X plus 8. Let's see if that works. Okay. So when x is 0, y is 8. When x is negative 8, y is 0. It's linear. That's good, right? Okay. So the correct graph, we had what? Negative 8, 0, and 0, 8. And I think the only one that passes through those points is C. Okay. Also, as a reminder, it's not guaranteed. Again, it's just if I can do it, as long as it doesn't skew the grades too much. I'm open to your overall MyMathLab score and adding that as extra credit as to count as 10% of your overall grade. So the higher your overall MyMathLab score, the more potential extra credit you can earn. Okay. So just if you did want to take time to try to maximize your MyMathLab score, you can take advantage of it. 68. Okay. For this equation, determine whether the graph, okay, so this comes from section 2.1, opens up or down. So the way a quadratic opens is determined by its leading coefficient. I think in this case, notice that we have a positive leading coefficient. So that means our quadratic should open upward. Okay. Final check. Okay. The vertex. So we have a vertex formula. Vertex formula is negative b over 2a. Okay. So in this case, it looks like it's going to be 2. Type in ordered pair. The vertex. So when x is 2, all right, we need to find the corresponding y. That's going to be a 4 minus 4 is 0, so look, it's going to be a negative 15. So 2 comma negative 15. That's an ordered pair. So when x is 2, the corresponding y is negative 15. And again, we got that 2 from negative b over 2a. Oh, let's see. We did that. Let's try it again. Negative b over, so 2 over 2, right? I did 2 over 1. 2 over 2 is a 1. When x is 1, it's negative 16. So 1 comma negative 16. 1 negative 16. All right, let's try that. So that's the danger of like doing this without writing it out. All right, if you write it out, you can see it better. If you try to do it in your head, you're more prone to make mistakes. Axis of symmetry is going to be the x coordinate of the vertex, so that's going to be x equals 1. Okay. Oh, x-intercepts. Okay, so for the x-intercept, we set y to 0. So if we set y to 0, does that factor? Two numbers that multiply to give us negative 15 and add to give us negative 2? Let me see. Is it 5 and 3? Negative 5 and positive 3? So then if it's x minus 5 and x plus 3, then the final answer is going to be negative 3 and 5. Negative 3 and 5. The y-intercept, all right? So y-intercept, you let x be 0. That one was oftentimes much easier. If x is 0, the only thing remaining is negative 15. So that one shouldn't be too terribly bad, okay? Using graphing tool to graph the parabola. Let me see. It'd be nice to be able to view our information. I think we said what? 1 negative 16 was the vertex. So over 1 and down 16 is about there. And then when x was 0, I think we were at negative 15. So I'm just going to use those 2 points. Now, if anything isn't clear, just stop me and we can talk about it. So if that were 68, 765, 432 is there. Okay. So this comes to section 2.1. Okay, so identify the graph. So this quadratic is in standard form. So in this form, we can quickly identify the vertex. The vertex is going to be negative 3, 0. Okay, so it can't be B or C. They have the vertex in the wrong place. It can't be A either. The only one that has the vertex in the proper location is D. So by process of elimination, we can go with that one. Notice that the leading coefficient is negative. It opens downward. All right, so I'm gonna go with that one. And I chose that one because that's the only one that had the vertex in the proper location. Okay, generate. Why is it staying in the 60s? 62, 63, 64, 65. Okay. I guess the random gods felt like we needed to focus on chapter 2 for a little bit. Determine the quadratic function of this form whose graph is given on the right. Okay, so they gave us the vertex and an additional point. So that means, let me see, our h is -1. So in the function, it's going to show up as x plus 1. Our k is 0. So it looks like we're going to have a times x plus 1 squared. And then it looks like a is 1 as well. Because if you let x be 0, right, then that means our a is going to be a 1. Because that's what that second point says. So then it just looks like we have x plus 1 squared. If I need to write it out, just let me know. So parentheses, x plus 1 squared. Okay. Let's check this before we submit it real quick. So let me see. When x is -1, we get 0. When x is 0, we indeed get 1. So this should work. It's a quadratic. Okay. Now let's get out of the 60s. It's like, okay, if I have to, I'll get just as far out of 60 as I can. So I think that's this one. Solve the quadratic inequality by sketching the graph. Okay. Let's see. Let's open up the graphing utility. Let's start with the vertex. So the vertex formula is what? -b over 2a. So we got a double negative, so then it's going to be a positive. So it looks going to be 4 divided by 2, which is 2. So our x coordinate is 2. When x is 2, we got 4 minus 8 is -4. So the corresponding y like is -1. So then the vertex is over 2 and down 1. That looks like it might be a little bit difficult to graph. We got it. So then let's plot the y-intercept. When x is 0, y is 3. I think we did not get it. We need to edit this one. So that needs to be a 3. Oh, not 32. 3. Okay, submit. Okay. All right, I think that's good. Let's hit save. Check. Okay, the solution set an inequality. So if this is the graph, the question asks, when is this quadratic positive? In other words, when is it above the x-axis? So it looks like it's above the x-axis on the far left and the far right outside of our x-intercepts. So x-intercepts look like it's what? 1 and 3. When x is a 1, we get 0. When x is 3, 9 minus 12 is -3, which is 0, right? So on the left side of on the left side of 1 and on the right of 3, right? So the way we capture that means the far left is going to be what? -infinity up to 1. Then we're going to say cup. And then from 3 to infinity. Okay. So this captures all x values that are left of 1 and right of 3. That's when the graph is above the x-axis. Okay. All right. Generate. Okay, 100. Hopefully that's the scores we're going to be getting on our finals. All right. We want to go to question 100. Obviously, you don't need 100, but question. Okay, how much should a father invest at the time his son is born in order to provide him with $60,000 at 18? Assume that the interest is 9% compound. Man, I wish I had an account earning 9%. Man, that would be so nice. How much would that be? Anyway. Okay. So let's see. How much should he invest? Okay. The future amount is 60,000. 18 years later, so the time is 18, compounded monthly. So that sounds like a compound interest formula. Okay, so let's take some notes on this guy. Okay. I just want a copy of the question just for reference sake. If anybody reviews this, you know where it's coming from. Come on. I don't know. It's like, it's really laggy. All right. Okay. So compound interest. So let me at least. So the main formulas that we have for compound interest, let me see. So we have our future amount equals P times 1 plus R over N. Let me make that a little bit more distinct. To the power of NT. That's regular compound interest. And then continuous compound interest is PERT. P to the RT. This is for continuous compound interest. Okay. So it says how much should he invest? So we're trying to figure out his starting amount. 1 plus the rate is 9%, so that has to be as a decimal, so that's going to be 0.09. It said it's compounded monthly, so that means our N is 12. 12 times a year for 18 years. Okay. So then we can use our calculator to crunch that. Okay. Oh, and we want to finish with 60,000. All right. So 60,000. So now we have P times some number equals some other number. So in order to solve for P, we just say 60,000 divided by whatever that number is next to P. All right, if that makes, hopefully it made sense. Okay. So we're going to say 60, 1, 2, 3, divided by this number. Let me see, 1, let me do a double parentheses. 1 plus 0.09 divided by 12. I'm going to close off that first parentheses. We're going to say to the power of 12 times 18. Close off the power and then close off the denominator. Okay, it looks decent. So it looks like you need to start with at least $11,945.91 approximately. Okay. So easy number, if he just starts with 12,000, with this account, if he lets this account sit until the son is graduated from high school, he'll graduate from high school with that amount. Okay, let's go here. Round to the nearest cent. Yeah. 11,945.91. Okay, let's generate. Let's go to question 57. What's the time? We got a little over 10 minutes. 57. Still hovering around the 60s for whatever reason. The functions f and g are given. Evaluate f compose g and find the domain. Okay. So composition, right? Composition of functions. This comes from sections 1.6. Composition of functions is what? One function inside of another function. So it's like the second function inside the first function. And so the way we kind of go about this, we write the first function like normal. Then we replace each x with a blank parentheses. And then in each blank parentheses, we put the second equation. All right, let me do that one more time, or say that one more time. So the way we go about this, the second function inside the first function, we write the first function like normal, right? So we would say something like f of x equals the square root of x minus 2, all right? Then we go back and we replace each x with a blank set of parentheses. Okay, so each x gets replaced with a blank set of parentheses. Then the function g goes into those blank parentheses. Okay, I think I'm gonna take my notes here. Again, second function inside the first function. Okay. Let me see. So we got our square root. Now we got this x minus 2. I'm going to go ahead and start with the blank parentheses. Again, I replaced my x with the blank parentheses. What goes into the blank parentheses? G, which is 1 minus 4x. All right, so now we have this new function where we have the second function inside the first function. Okay, so then we can do some algebra, combining like terms. So 1 minus 2 is going to be what? -1. So it looks like it's going to be the square root. It looks like it's a -1 minus 4 x. I think that's as far as we can take it. Let me get rid of these notes. 1 minus 2 is -1. Yeah, let's get rid of all this. Okay. So that's the first part. Yeah, that looks good. Okay. So then now, again, that open circle, right? The symbol here, if I can, let me do it today, please. Okay. So I know that's tempting because I was tempted to say it and I kept having to intentionally. So the question popped up, wouldn't that be imaginary, right? So I'm glad you asked that question, right? So it is tempting to try to factor out a negative, then you're going to have a negative inside the radical, and you could kind of express it like that. But so, keep in mind that with the domain of square root, we can't take the square root of a negative, right? Because we have that variable on the inside, right? That means that radicand, that part on the inside, has to be greater than or equal to 0. I'll take a little bit of notes here. So there's -1 minus 4x has to be, I don't think I can get the symbol. Let me see, greater than or equal to, I got it, cool. That has to be greater than or equal to 0, right? So then from here, if we solve for this inequality, we add the 4x to both sides, divide by 4, you'll get -1/4 is greater than or equal to 0, right? So I'll just do a comma. We ended up getting a -1/4 is greater than or equal to 0, right? Is greater than or equal to x. So what we're saying is that as long as x is less than or equal to a -1/4, then it won't be negative inside the radical, right? So for instance, if we chose x is 0, we're going to get a negative inside that radical, right? But if we chose x is like -1, we'll get a positive inside the radical. Right, but that was a great question because I was thinking about that while I was saying this other stuff, and then you kind of read my mind a little bit. You had the same you noticed the same thing I noticed, so I'm glad you asked it. But yeah, so that's the only reason it's not imaginary is because of the x value. Because now this is basically saying, well, if you choose any x less than or equal to 1/4, then you're guaranteed for the inside part to not be negative. Right, mainly because of the variable. Okay, so that's a little bit of backstory on why it's not imaginary. But there's a different. We might get a similar answer, but there's a little procedure that I like to do whenever it comes to composition of functions. I like to do this 3-step procedure to find a domain. Right. Whenever I'm working with composition, the 3 steps is first we find the domain of the inside function. Then we find the domain of the simplified function, and then we take the intersection, right? So I think we just had the domain of the simplified function. That was the -1/4 is greater than or equal to 0. So that's the domain of the simplified function. That was like step 2. From step 1, the domain of the inside function is going to be the domain of G. I think that domain is all reals. It looks like it's a linear, right? It's just a negative slope, but the domain is all reals. So the domain of the inside function is all reals. The domain of the simplified function is this, and it's an x, not a 0, did the same thing. X is less than or equal to the -1/4. So then the third step will be to take the intersection of those two sets, right? All reals intersection this other set is going to be just this other set, right? Because the all reals has everything and has a whole bunch of extra. So we get rid of the extra. The things they have in common is going to be this guy here. So then this guy, we just need to put it in interval notation. This is like set notation. We need to convert it into interval notation. So again, the alligator's eating the bigger thing, right? So that means that our values, if we look at the number line, do we want to keep the numbers left of -1/4 or the numbers to the right of -1/4? Well, if the -1/4 is bigger than our numbers, that means we want to keep the numbers to the left. Our numbers are all the numbers to the left of -1/4. So then we capture that by saying negative infinity up to a -1/4, and that and we can be equal to 0 in this case, right? Because we're not in the denominator, so we need to use a square bracket there. Okay. So the claim, now that was a little bit extra, right? And I know I didn't write it out, so I'm kind of doing this audibly. Not kind of. I mean, yeah, I guess it is kind of because I am typing some of it. So you have to really like pay attention to get it. Let's recap this real quick. So composition of functions, f of g of x, right? The second function inside the first function. The way we find a simplified function, we write the first function, in this case f, we write f like normal, square root of x minus 2. Then we replace each x with a blank parentheses. All right, we replace each x with a blank parentheses. And then, I don't know if y'all know that reference or not. Kind of showing my age, but I don't care, right? I'm just gonna lean into it, getting older or whatever. I'm gonna just lean into it and just accept it. So anyway, we wrote the first function like normal, and then we replaced the x with the blank parentheses, and then inside the blank parentheses, we put the second function, that 1 minus 4x. We put the 1 minus 4x into all the blank parentheses. Then we use algebra to simplify. We got the grayed out part at the top, right? That square root of -1 minus 4x. We had an excellent question, isn't that imaginary? And then we showed that, well, okay, for the square root, we can't take the square root of negative, so the radicand had to be greater than or equal to 0. So as long as x was less than a -1/4, then it wasn't going to be imaginary, right? And then we had to find the domain of a composition of function. Again, when it comes to finding the domain of a composite function, there's a 3-step procedure that I like to do. Step 1, find the domain of the inside function. And the inside function was g in this case. The domain of g is just a linear in this case, so that means the domain is all reals, right? The second step is find the domain of the simplified function. That's the grade part. That's the part that we had found earlier, right? When we were exploring if that were imaginary or not. So the domain of the inside function just happened to be from -infinity to -1/4. And then the third step is we take the intersection of those two sets. So this set that you see on the screen at the bottom, intersection all reals, is going to be this set itself, right? Any set intersection all reals is itself. Okay. So this should be it. Let's go ahead and submit this. That was a funky little adventure. We got a solid 5 minutes. Let's take advantage of it. Let's use the 5 minutes. I don't know about you all, but I've already been enjoying my holiday break. I'm always at the movies. So I did sign up for like AMC has like a movie pass. Like back in the day, I don't know. I guess when I first started working at Morehouse, there was this company. It was called like Movie Pass, and so with that program or whatever, it allowed you to see like one movie. It went out of business because they didn't market it right. They didn't price it right. Whatever they had going it just wasn't done. They didn't have me in their field to say, hey, these numbers aren't going to work out. You gotta either increase your price or do something different. But basically, with that program, it allowed you to see one movie every day. And so I guess theaters realized how popular it was for people. So they stopped doing business with that company, and they just each theater kind of did their own version of that. So I ended up going with one. Fast forward a few years or whatever, and it resurfaced at AMC. They have this whole AMC's A-list stubs or whatever membership, where I signed up for the one for the year. So basically, every week you can see three movies. So I've been every week, and I try to go out of my way to use those three tickets. So I watched like Wicked. I don't want to say anything about Wicked, so it's like because I don't want to spoil it for you guys. So if you want to see it, I would encourage you to see it before, if it hasn't already been spoiled. I saw Red One. You saw all the movies. Heretic was stupid. I'm gonna spoil that one. It was. I think he made a good point, but the way they went about it was like weird and kind of dumb. But anyway, just having fun. Red One, all that stuff. Just fun movies. Okay. So that was fun eating up some time. We got a solid 3 minutes. Let's go to 110. Better. So, but yeah, I like it. I do like that they have a yearly subscription. You pay once in a year, and you can enjoy it all year. So whenever I come across yearly subscriptions, whenever I can take advantage of them, I like to sign up for those, because then you always get to that point at different periods in the year where you might not, you might just be down and out, but you still got things you can do because it's already paid for the year. And so, take this if I don't have to be the one to capitalize on it. It would be nice, but I don't have to. But I like that concept of yearly subscriptions. How about extending that to like rent or mortgages, or extend that to like utilities? You pay one bill in a year and you don't have to think about it for the rest of the year, or extend it for like a few years or a decade or for a lifetime. That would be awesome. I don't know how marketable it is. I don't know as far as the numbers, the feasibility of it, because they're always, trying to figure out how to make us pay for things that are free, like food and power and stuff. But I would enjoy something like that if I had a community, tiny house community, something where we can pay for months at a time. I think that's what they do in France. Like they only work. I'm under the impression that they only work like maybe 3 or 4 months out of the year, and then the rest of the year they can do whatever they want to do. I was like, yo, I need that in my life. Anywho, again, you have to do your own research to decide. I'm just saying that's the impression that I get. That's my understanding. But that's not my forte. Okay, so the coffee counter charges $7 for Kenyan roast French coffee or whatever, and we're just talking about France. It is $6 per pound for Sumatran coffee. How much section is this? Okay, system of equations. Okay, 6.4. How much of each type should be used to make a 20-pound blend? Okay, I remember this. All right, I want to give this one a go. I got literally 2 minutes. The blend ones. Okay. Let me try this, because I used to have a system here for things like this. Do I want to do that? Yeah, I think we can get it. Let me see if I can get this working, because I think I do need to think about this one for a little bit. I don't know if I have enough time to do it. That's the challenge. Is trying to get it in like a minute, because I need to think about it for a little bit. All right, let me just off of memory. Let me see. So the coffee, it charges $7 per pound for Kenyan French roast. Okay, so $7. So we'll let KB each pound. So 7K. Mm-hmm. And 6 for the Sumatran. Okay. How much of each type should be used to make a 20-pound blend? So if we have K pounds of the Kenyan plus S pounds of the Sumatran, we want it to be a total of 20 pounds. And then this is the price. So $7 for each pound of Kenyan plus $6 for each pound of Sumatra. And then we want to finish with 6.6 for each pound of the blend. How do we capture the blend? Do we need a K plus S? Okay. Let me see. I think. Okay, because I'm trying to be quick. I see the time. Let me check one thing real quick. So I'm going to click on the view, get more help because I know we're just one thing away. View an example, and I'm just going to go to the end. This is similar with different numbers. We got that part. Yep, we got that. We got that. Oh, okay. Okay. 207. I see. It sells that per pound for 20-pound blend. What about the first part? Where's the other equation? Oh, okay. I got it. We're there. All right, I think we can wrap it up. So it's going to be $6.66 per pound for a 20-pound blend, right? So the only thing we're missing was the 20 there. Okay, I think this is it. We got a system of equations in two variables. Let's try to solve. What's the simplest way? I think I'm gonna do substitution. I'll solve for k. So from that second equation, we get that k equals 20 minus s, okay? So then if we take this and plug it into the first equation, we're going to have 7 times 20 minus s plus 6s equals 6.6 times 20. Okay, I'm trying to wrap this up and get you guys out of here. We distribute here. 7 times 2 is 140 minus 7s plus 6s equals, I'm still leaving this for right this second. Let me see. So negative s equals 12, 13.2, 100, 132. I think that's right. Minus 140. So, okay. We're going to get a negative result. Multiply both sides by negative. What is that difference? 8 pounds? Looks like it's 8 pounds of the Sumatran blood. Okay, so if that's 8, so then the other one looks like it's 12. Okay. Interest of time, I'm just going to submit this. Hopefully, we got it right. 8 and 12. Come on. Kenyan roast was. I forgot this that quick. Kenyan roast is 12. Okay. Now my device is trying to click on this thing. 12 and 8. Let's go. Okay, so it's the X here. I'm getting you guys out of here. 12 and 8. Come on. So trippy. 8. There we go. Cross our fingers. Awesome sauce. All right. Again, there was one part I wasn't sure about. I looked it up real quick. So again, the way I use that whole get more help, I mean, hopefully you guys have discovered that by now. The viewing example, that's my favorite tool. Also, the Ask My Instructor is powerful too. It'll take a snapshot of your very question and send it directly to me. Okay. If you want my input, you don't necessarily have to get my input. Okay. All right, gentlemen. If there aren't any burning questions, wait, let me check here real quick. Okay, we answered that one. All right, gentlemen. So happy holidays. It's a good it's a good opportunity to get caught up on some work, but be sure to spend time with your friends and family whenever possible. No day is promised, so try to give your loved ones their flowers while they're alive. Right? Try to honor them and let them know how you feel about them while they're alive. Don't wait until tragedy strikes before you try to do something like that. All right, beautiful people. Happy holidays, and I'll see you in 1 week. With that, we're going to end the session here. From one beautiful mind to another. Happy holidays and take care. See you in a week. Peace. Safe travels and everything. As we the same. We the same. All right, let me go ahead and do attendance. I'll check that momentarily. I'll stay on the call for a hot moment in case anybody needs me. Let me see. Let's go to Zoom. Sign up. Come on. Let's go. Sign in. Single sign on. Reports. Usage for today. Oh, maybe it's because I guess I got to end it before to show up. Okay, gentlemen. You still here? That's fine. Let me check. Let me check. Let me see. Switching from a phone. That's cool. The date. So the final. I don't know if you're still here. The final is going to be available for like 5 days. So from Sunday to about that Friday. So you'll have extended time to work on it. It's still unlimited attempts, and the system is set to take your highest score. Excellent question. All right, gentlemen, I gotta shut this down.